You might be planning on creating a website or server, but are wondering how everything works, and more importantly, how to get your server off localhost and onto the web. So, first off, let me start with an actual website. So, a website is just HTML and CSS and a bit of JavaScript, and it's really easy for you to just put it on something like GitHub, and GitHub could just give people these files really easily. So right here I have and one of the ways that you could deploy your website and make it accessible online is using GitHub Pages. So in GitHub Pages, you could just leave these files inside some GitHub repo, and I'm assuming you know GitHub. Pretty much it's a place where you could store a bunch of files, and the technology which it's based on allows you to track these files and track their changes. So pretty much I put a bunch of HTML and images on to this website or onto this repository, and I put it on something called GitHub Pages. So I could go to my GitHub Pages uh, website, and I could actually see this website that I've created. And this is nice, but the problem is that it's only static files. So you could serve HTML, you could serve CSS, you could serve JavaScript, but every time you refresh the page, it's going to be the exact same experience. So you not only want a front end, which is a website, but you also want a back end. And one simple project that I've created a while back is this URL shortener. So pretty much the way that URL shortener works is, first of all, I made like a website GUI to just allow people to add URLs. So pretty much the way that works is that I have some server, and this server contains a bunch of HTML files and a JavaScript file. And whenever you go to the root of the server, then it would give you this HTML file. And then this HTML file will give you this JavaScript file. So let me just show you that file. So pretty much the server, it is pretty much using some framework called Express, which it uses JavaScript. And most frameworks are very similar to this, at least uh, web frameworks, wherein you could just uh, state that you want a certain directory to be served whenever you ask for a certain URL. So pretty much what's going on here is that on this server, whenever I ask for the root URL, then it's just going to serve from this file, so the public file. And the public file contains an index.html. I could write some HTML inside here, and it would display it on my website and or on the URL which I have specified. Well, which it's localhost in this case. And inside this HTML, there's a JavaScript file, so it's also going to ask, okay, I want the JavaScript file as well. Um, but in this case, this server is running on some port. Now, a port is some ID for a process on your device. So you could think of this all as your device. So I'll just add tiny computer logo, and pretty much um, in every device it has a bunch of ports. So this server is going to be running on port 5000 on my local computer. So if I wanted to access this server, I would go to localhost 5000, and as I mentioned, it's serving all the files inside this public folder, and it's searching for the index.html file. That's how it's configured. And when I make a request for this, it's just going to serve me this HTML, and it's going to be rendering on my browser. Now, HTML and CSS and JavaScript is nice, but you actually want to do something unique every request, or you want to save some data, you want to um, serve this data and edit it and so on. So in a server, you not only want to be serving some static files such as HTML, CSS, but you also want to be serving requests or listening to requests and giving back a response. Now, as an example, I'm just going to open this shell that I have and just make a request to verbosely. So it's going to tell me everything that's going on to localhost 5000. And as you could see, it tried going to localhost, and then it made a GET request to this thing. And then there's a bunch of headers that's going to become important later on. And then the server would send back a response. So this is the response, and it has a bunch of headers as well, but more importantly, it has the HTML itself. So this is the HTML file which I specified over here. And like I mentioned, you not only want to be serving HTML files, but you want to do something more interactive. So over here, I not only have these HTML files, like the only thing, I'm not only serving these HTML files in the server, but I'm also allowing people to create URLs inside my server, as well as get all the URLs. So let me just check over here. Okay, if I make a request to /all, what's going to happen? So I'll run the same command, but I'll run it all. And now you see a bunch of JSON data. So if I go to /all here, you're going to see a bunch of data. So over here, this is actually checking the database. So I have, not in this server, not only do I have a bunch of HTML and JavaScript files that is being served, but I also have a database, and you could represent it like this. So I have this database, and it's storing all the data inside this server. And whenever someone makes a request, it checks this database for some information, and the database would respond to this request, and then it would serve this data to whoever is trying to access the server. Now, if we look at the code, then you could see that it has a request, but I'm not using anything inside this request, and there is a response object. So pretty much what's happening is I'm asking the database find all the URLs and just return as JSON. And if I look at this raw, pretty much this is going to just give me all the raw information about this request. And as you could see, the content type of the response is JSON. If we look at the request that I made above, it's actually sending HTML. So this is the HTML file. Now, I showed you how to get some HTML and get the data on the server. But how about creating stuff? So there's actually something called HTTP actions, I believe. So you could get data, but you could also post it and delete and put. So what does this mean? So get means that you just want to get some resource and have it sent back to you. So it's not going to change anything. Post is when you're creating new data. So you're going to be adding some more data to the server or whatever, or you're going to be pretty much adding something new. Put is if you're going to be editing some data. So you have some data and you want to actually modify this data on the server. So you're going to make a put request. And delete is self-describing. So you have some resource on the server and you want to remove this resource. So you would use the delete action. Over here, I just have a post action, and now you want to actually specify what resource are you trying to do this action on. So as I showed before, there is the /all resource, and when I make a request to this, it sends me all the JSON data on the server are all the URLs on the server. But let's say that I want to actually create a URL. So what I would do is I have this form, and this form, and there are multiple ways of creating forms, but a really simple way of doing it using just HTML is just creating some form, and it's telling, um, it's specifying, okay, what's the method, and my bad, these things are called HTTP methods, and it's saying, okay, what exactly are you going to be doing? Are you going to be creating data or getting data? And where should this request be sent exactly? So it's being sent to the /create action. Now, if I say, okay, I want to get some URL, such as this maybe GitHub Pages URL, and I could say that this is going to be the URL that I want to shorten, and I also want to specify what name should I give it. So I'll just call it Pages. And if I go to the Network tab and read what is going to be sent, it made a request to /create, and it has given me back some data. Okay, now let me go back to the server and take a look at what happened. So there's the post method, and it's going to create. So it's listening to some post request on the /create route. That's what it's called. And I made a request like I've shown you here. So I made some requests and I gave some information, like for example, what method am I going to be using and what resource am I going to be aiming or targeting. And I believe if I check over here and look at the headers, so here it's using the post method and it's directed to /create. And I made a request, and this request has a bunch of data. So it has the it just has a bunch of data over here. Let me see if there's any interesting stuff. Okay, so there's the form data, and this is in the body of the request. And it's saying, okay, this is going to be the URL, and this is going to be the shortened URL. So pretty much this is just a bunch of data inside this body, in the body of the request. So in the server, I could take this request, and this is irrelevant, but I could say, okay, I have the body, and I want to get some information out of the body. Now this is just some JavaScript um, shorthand stuff or syntactic sugar, but I could just say request dot, and it's a bit too small, but request dot body, and then I could pretty much get the URL out of it, and I could get the shortened uh, data out of it. Now I could check, I'm checking, okay, make sure that there's the shortened data or the shortened variable and the URL variable, make sure it's defined. And then I'm going to check, okay, has someone else already, I'm going to check in the database, has someone else already taken this shortened value? And if it has, then I'm going to say, okay, the shortened name is taken. So let's just try that out. It's been a while since I checked my code, so I was surprised that I checked this. Okay, and then it says, okay, shortened name is taken. So that's exactly what happened over here. And there is a 400 status. Now, the way that in the HTTP protocol that you could tell what exactly has happened in this request is via the status. Now, 400 status means that it's a bad request. If you make a 400 status, or a 200, if you get a 200 status, that means everything is fine. And if I just create a new URL, then it's going to be 201. So you're creating some resource. Okay, now what's going on if it isn't taken? So it went to the database and it created a new URL. And this is just what I named on the database, but pretty much it would create a new URL with some data. So this is the URL, this is the shortened URL, and then it just returned a 201 status, and it returns some data, and the data is the actual resource. Now if I look over here, okay, this is the created resource, so this is the URL, this is the shortened URL, and some ID. So in the database, to quickly access some resource, you're usually going to be using the ID, but I'm not going to be using it here. Now, okay, you might be thinking, what is the point of all this? So the point of this application is to actually create a URL shortener. So if I go to localhost 200 and go to Ryan404, then I'll be redirected onto my GitHub Pages site. And if I were to go to this Pages resource, then I would be redirected to pages.github.com. Okay, so how does this work? So I could look over here, and pretty much what's going on is whenever you make a request, a GET request to this resource, so slash and then some parameter, so the dot signifies some parameter, then it would go to this route. So it's going to see, okay, you're trying to make a request to this, so what is shortened? So it would check in the, so I'm checking in the request, okay, have you made a, have you specified some shortened URL? And if I have, then it would just ignore this, but if I haven't, then it would say, okay, what are you trying to do? You should specify a shortened URL, but I don't think that this code is really necessary. Let me try it out. So I could say 500 and then that, so bad request. So pretty much if this does not exist, I mean if there's no shortened URL, then it's just going to ignore, it's going to tell you, okay, you made a bad request. And here it's going to check, okay, find some resource in the database that has a value or a shortened value of this, and some more Java syntactic sugar, and this should actually be 404. But pretty much if it isn't found, or some resource isn't found, then you should return a 404 response. And if everything has gone well, then it would, and it found this resource in the database, then it would redirect you to the URL which you specified here. So pretty much that's how this application works, and it allows for more dynamic stuff to occur. Now this is just one kind of server, and most of what you're going to be seeing in web applications is stuff like this. So you're just getting, creating, reading, or it's something called CRUD. So create, read, update, and delete. And that's pretty much how websites work. Now, there are other ways that you could use servers. So you might be wanting to create some Discord bots, for example. So this Discord bot, it just cheers whenever you say cheers on this Discord channel. And it could be something like a game server, like for example a Minecraft server. And personally, I actually created a Minecraft server and tried deploying it locally. So we talked about deploying some website on GitHub Pages. Now, how about trying to allow people to access this server that I have locally? So if you want to do that, then you want to do something called port forwarding. So this is your computer. Your computer is connected to your network or your home network. And in your router, which is connected to the internet, you could specify, okay, in my computer, uh, whenever you make a request to, like, let's say port 80, which is the standard HTTP port, then redirect it to port 5000 in this computer. So like I mentioned, port is a unique ID for the process that you're running, and you could specify it when you're creating your server. So now let's say that this is your network, and you've port forwarded, as in you said that, okay, if I make a request to my network or to my router, and your router has a certain IP address, which I'll cover in a sec, then redirect this request from the router onto my computer onto port 5000. But there are lots of problems with that. First of all, if someone tries hacking you, is going to become your network is going to become hacked. So you don't want people to really know what your network IP is. And second of all, your network IP is IPv4, and the world is actually running out of IPv4 addresses. So usually what the internet companies do is they change your IP4 address a lot. So you're not always guaranteed to know what exactly your network IP is. Now what you could do is get a virtual private server. So you have your own computer, and your own computer, you could write programs on your computer and run them. Now, what a virtual private server is, it's pretty much some server or some computer that you rented on the cloud, such as AWS or Linode or wherever, and pretty much they assign some IP address to this, like say 70, 70, 70, and depending on what service it is, it's probably not going to change. But yeah, but then you could write your programs on here and you could run them. But to connect this virtual private server, you might want to use some protocols such as SSH or some other means. Now, right now I have on my own network, I also have a Raspberry Pi. And now if you've never seen a Raspberry Pi, then I'll just show it to you right now. So pretty much it's a tiny computer that's the size of a credit card. But what I used to do is I had a Minecraft server on my Raspberry Pi, and I port forwarded it. So pretty much whenever you try accessing some port, let's say 2000, then it would go to my Raspberry Pi, and it would allow you to connect to this Minecraft server. And that's a fun way of trying to learn how to create and manage servers. But you might want to use a VPS. Now, a VPS is usually some paid service, and I don't want to have one right now, but I could access my Raspberry Pi. So pretty much, if I know the IP address of it and I configure it to work with some protocols such as SSH, then I could actually connect to it. So in this case, I'm going to be using my Raspberry Pi for an example. This is going to be 192.168, I believe, that 1.38. And I could just connect to my Raspberry Pi using my terminal. So I could say SSH and then just connect to this IP address. And I connected to my Raspberry Pi. Now I could actually tell it to do stuff. Like for example, let's see. So there's something called netcat, or I'm not going to do anything too complicated, but pretty much you could run commands on this and run servers on it, and then you could connect to us. There's some command called netcat. Let's see if I could get it running, but I could say netcat listen on port 80 perhaps, or let's say 6000. So then it's just going to be sitting and waiting for a request. So netcat just pretty much waits. It's a really simple server. So the way that works is that it just waits until someone makes a request to it. So if I go to 192.168.1.38 and I go to port 6000, then I should make a request here, but it hasn't. Let me try that again, but on port 80. Yeah, so pretty much I made a request to port 80, and I feel like it's probably due to like some firewall settings, but pretty much I made a server on port 80, and I tried making a request to it using the browser, and it made a HTTP request. So it tried getting the slash or root, and it just sent a bunch of issue data in the headers. Um, Now this is really similar to like some creating like some server on a virtual private server, but the problem is that you actually need to pay money to create this to use some virtual private server. So if you want an actual, if you don't want to just send normal HTML, like for example with Google GitHub Pages, then you actually need some kind of server. And what I'm using right here is something called Heroku. So Heroku allows you to um, connect to some server. Let me just go to the main website. So pretty much Heroku allows you to create some servers and run them on their platform. And it's mostly free, but it's slow sometimes, and it actually turns off if you haven't been using this server for a while. So pretty much over here, I have this server running on localhost, and I've deployed it to Heroku, and I've given it a subdomain, which is rs shorten, and I could make a request to this subdomain. Now I think that's turned off, but if you just give it a minute, then it would turn back on. And while talking about that, I'll just show you the actual database that I've been using for localhost. So I've connected to it using the something called MongoDB Atlas, and you could see all the data that's inside this database. So um, as you could see, on this page, I've gotten all the data that is on my database. Now, if you wanted to just see it as JSON, you could go to /all. But this data needs to be stored somewhere. So I'm using something called MongoDB. It's not the best database, but there are many different kinds of databases, from MongoDB, which is NoSQL, or not only SQL, uh, or you could just use some traditional SQL database such as MySQL, PostgreSQL. And over here, this is just the database that I'm using on localhost, but on the cloud. This is the data that's on it. Now, if you look over here, this is my Twitter, and as you can see, this is the data that's stored. So pretty much it has a URL, it has some shortened URL. Now, if I just go to this/Twitter, then it would redirect you to my Twitter, or at least my Twitter. So now it would redirect me to my Twitter page, and there are a bunch of other things that you could check out. Let's see. Now, an alternative thing that you could do is something called containerization, but I wanted to cover something else before that. So there's also something called Vercel, and I use this for my main websites, such as ransoman.com, not my GitHub pages, but my actual website. So if you've been wondering how have I deployed this, where have I deployed this on, I use Vercel rather than GitHub pages. And it's much better for more complex front ends such as React or Next or Gatsby. So that's what I've been using, and pretty much, yeah, so you could connect there. They also have my own domain name. So how does a domain name work? So let me just exit from my Raspberry Pi and let me just ping my own website. So if I ping ransoman.com, it actually gives me some IP address. So if I go to this IP address, then and try connecting to it, it actually sent me to Vercel. Um, so like I mentioned, it's being deployed in Vercel. Um, Let me do something different, like for example on google.com. So if I ping google.com and it gives me some IP address. So what a domain name is pretty much just some abstraction over the domain name. So or the actual IP address. So from the domain name, it goes to something called a DNS server, and the DNS server pretty much gives you this IP address. And the IP address is what protocols know how to connect to. So if I try connecting to this, then it would bring me to google.com. Um, Now the benefits of Vercel is also that you could buy some domain name and you could actually create subdomains pretty easily. And as you've noticed, it's using something called HTTPS. So for something to be HTTPS, it needs to have an SSL certificate, I believe, or a TLS certificate. And if you look at localhost, it does not have that padlock. Now, Vercel gives this for free if you have a website there, which is pretty nice. And the last thing that I wanted to talk about is Dockerized applications. So on the cloud, I have the actual server and yeah, I have the server running on, like on the case of Heroku, I have the server and the server has the pages and it has the code that's checking the database and so on, but the database is on another server. So it's on something called on MongoDB Cloud, I believe. And the problem is that this is pretty slow and it is quite different. Like if you were just developing on localhost, then the conditions are kind of different to when you're actually deploying it to the cloud. So rather than doing that, and also maybe you not only want a MongoDB database, but you also want other services. So things get a bit complicated, and there is an alternative way. So using something called Docker. Now I don't have a actual example for you right now, but I'll try explaining it to the best of my ability. And for my next projects, I'll probably be using this. So pretty much with Docker, there's something called a container. So you could think of a container as just a box. And this container can contain other containers, such as the database and other services. Maybe, for example, Redis. I don't know how to write the logo, but pretty much if this container runs on my machine, then it would probably run on the server as well with minimal other configuration. So it makes it really easy to develop. And if I wanted to, actually this is not that accurate, but pretty much you could think of this as my container, and this is the network that my container is on. And I could have other containers with my database with, for example, Redis, and maybe my server becomes too slow, so I could just create another container really easily, and it would scale it uh, really easily. So there's lots of advantages of um, deploying your project in this way, but it's a bit more complicated. I believe there's something called AWS EC2, so it's something like Elastic. Let's see. Um, yeah, but pretty much you could deploy it on AWS. Now, this is not going to be free, but it is the best for a large application, such as what I'm planning on doing in the future.